Hello. This video, which I call Part 2 ABC, is to answer questions posted in comments to Part 2. See the link below. I very much appreciate your input. The first question: since every rectangle can be split into two right triangles by drawing a diagonal, does that mean every rectangle math problem can secretly be solved using trigonometry? Answer: not just for rectangle, even broader. In this video, we will go as far as parallelogram. We briefly refresh on definitions of square, rectangle, and parallelogram here. But focusing on how a diagonal divides those shapes exactly as asked. A diagonal divides square into two congruent triangles. Now let's draw a rectangle. Every square is a rectangle, but not vice versa. Those are definitions of square versus rectangle. A diagonal also divides rectangle into two congruent triangles, but here is the difference. A square is divided by diagonal into two congruent triangles, which are right-angled, pi by 2, and isosceles, two sides are equal. A rectangle, though, is divided into two congruent triangles which are still right, but not isosceles, two sides are not equal. Some equations in the right bottom corner. Refer to Part 1 and especially Part 1-ABC, links below. The next page, we introduce a parallelogram, but before we do, the triangle sign rule shown in blue for the special case of a right triangle, gamma equals pi by 2. Compared to the equations listed in the previous page. Now definitions of rectangle versus parallelogram. A diagonal divides rectangle into two triangles, not isosceles, but still right-angled. A parallelogram, though, is divided into two triangles, which are still congruent, but not right-angled anymore. Amazingly, the triangle sign rule still holds true. Shown here in blue, it deviates from the one in previous page in just one little detail. Can you find it? Quite simple. We can choose another diagonal to divide parallelogram, its length d, angles alpha and beta are denoted with quote an angle phi instead of gamma, but the triangle sign rule still holds true. Because it is true for any triangle, not necessary right-angled, not necessary isosceles. We also briefly mention triangle cosine rule here. When angle gamma is the right one, it reduces down to the Pythagorean theorem. Else it's a generalization of Pythagorean theorem. While all parallelograms are quadrilaterals, not all quadrilaterals are parallelograms. There are other special type of quadrilaterals that can be solved using trigonometry, like kite. But that's outside of our scope.